On distribution switch 1, you can see VTP domain names, mode, then interface, DTP protocol for trunking. After that, VLAN 10, 20, 30 are allowed. Let me show you the access layer switch configuration first. Yeah,
Have
here
you
is
ever
access
shared
layer.
that?
I've used some user in VLAN 10, some user in VLAN 20, some user in VLAN 30.
Excuse me, sir. Have you ever shared that
What?
with us?
This was your task, bro. Why I will share this command? Later I can see when you will configure. This was your assignment. I think you forget previous class. This is the
Okay.
lab commands from one of students from the same batch only who did the configuration. So just I am showing you his configuration. So he had put it these two PC in VLAN 10, these three PC in VLAN 20, and PC 6, and the server in VLAN 30. I think this server is DHCP server. After that, on distribution switches and access layer switches, you can see the configuration. On access layer switches, we have assigned the port G0/3 in VLAN 20. Great. Switch port mode access, switch port spanning tree, port fast. Then interface G0/2 is a member of VLAN 10. VTP domain name Cisco client mode. Let me do one thing. Let me copy his commands and let me paste it on the switches. On access layer switch 1, or let me paste first commands on distribution switches because distribution switches are VTP server. On the distribution switches, C commands. VTP domain name Cisco, you already know this server interface range 0/1 to 0/3, 0/1 to 3, these interfaces. So I'm configuring encapsulation protocol .1q on the trunk. After that, switch port mode dynamic desirable so that this link can become trunk, and then we are only allowing VLAN 10, 20, 30 over trunk. Then ether channel for these two links mode on. After that, VLAN 10, VLAN 20, VLAN 30, you have created VLAN 3 VLANs. Then SVI interface for all the VLANs. After that, G1/1.
Sir,
Yeah.
the assignment was about HSRP.
Uh,
This doesn't have HSRP.
HSRP is there, na?
I haven't seen any standby.
This is not the console of switch. This is notepad.
Yeah, I know, but is there a HSRP configuration on the notepad? I haven't seen one.
Maybe in the below they have added the command for HSRP separately. Before that you need topology. So this is the base
Okay,
configuration,
okay.
right? Or you can add the command on interfaces if not there. Standby.
Yeah, that was our assignment, and we are going to use
Yeah, and
switch virtual
before a standby
interface.
configuration you have to perform base configuration.
Okay.
Then only HSRP will work, na? Right,
Yeah,
before
but we
configuring
didn't have
HSRP
we.
here, what I did, I configure IP addresses on the router. I make
Yeah,
reachability between clients and PC.
we were not supposed to have ether channel between the distribution switch, for example.
Yeah, this
I
is
didn't
base lab.
configure that.
So this is
I did
complete
only.
configuration of distribution switches,
Okay.
right? You already know the meaning of all the command. Here on the VLAN interface, I will add this command standby number 10 IP 192.168.1. For VLAN 10 is using this subnet 1.0, 2.0 and 3.0. Let me write here the subnet for all the VLANs. VLAN 10 subnet is 192.168.1.0/24. VLAN 20 subnet is 192.168.2.0/24, and VLAN 30 subnet is 192.168.3.0/24. right? And on distribution switch 1, SVI interface for VLAN 10 is using IP. What IP?
100.
100. Here 100, 2.100, and here 3.100. These are the SVI on distribution switch 1 for these 3 VLANs, and on distribution switch 2, 101, 101, 101, and 101. And then on this SVI interface, you are going to add this command standby. And let's say my virtual IP address is 250 for the last IP address from the subnet. I will add this command here on VLAN 20 interface, standby group number 10 and 2.254, and on VLAN 30 interface, standby group number 10 IP 3.254. On distribution switch 2 also I need to add this command. For VLAN 10 IP address, virtual IP address 1.254, here 2.254 and 3.254 on VLAN 30 interface, right? And for the routing between distribution switch and a router, right, you can see the IP configuration, right? These interfaces are L3 interface. So directly I'm going to copy distribution switch 1 commands and I will paste on this switch 1. Let me access it. Distribution switch 1, and let's paste all the commands. There is some issue, let me verify. IP address on VLAN 10 interface. What is missing?
Mask.
255, 255. Yes,
Subnet mask.
yes, subnet mask.
Not here, but here. And for VLAN 30, here. Anything else? Let me correct it on the switch 2 as well. For VLAN 10 interface, subnet mask this one.
Sir, if you can change the host name, it would help.
We'll do that. Wait. IP address. Is there any other mistake? IP address. Now let me try to paste the command. And here I'm also going to update host name. Host name D switch 1. Copy and let me paste. Standby for VLAN 10 interface. Still there is mistake. VLAN 10, it should be not here. It should be here. Now all the commands are accepted. I'm going to copy commands of distribution switch 2 as well. Distribution switch 2 has also similar configuration. And here which switch will become my active switch?
Switch 2.
VLAN created, IP address, okay, this is interface configuration. Here is a mistake on D switch 2. Copy and paste. D switch 2 will become root bridge. Sorry, I'm saying root bridge like active switch.
Yeah.
No switch port command and then this command. No. Here if you will check, your switch number 1 is the distribution switch. 1 is the distribution switch 1 is the active switch. Why? See here the log message, and so standby. Here also you can see on distribution switch 1.
A higher IP address, or if it's the same priority, it
Active switch is
checks
the
IP
local
address.
switch. Active switch is the local switch. Distribution switch 2 is standby. So standby. You can filter the output as so standby question mark brief. Here you can see for VLAN 10, 20 and 30. This switch is
Standby. Standby.
the standby switch.
You want to change the host name here too, so we don't get a little confused, please.
Why distribution switch 1 is active? Switch 2 should be active, right? We know this.
Yeah. Does it have a higher IP address? Switch 1? I'm not sure.
But distribution switch 1 is the active switch. Why, guys? Because
It was
Has a
preemption,
higher
configured.
priority.
not higher priority, bro. Preemption
It
is
was
disabled,
configured.
right? Active router is already elected, already there. If active router is already elected and then any switch is coming up in the Hsrp with higher IP address or higher priority, will that switch become active switch or active router?
No.
No. If preemption is
Friends
disabled,
will
then
respond.
no. If you will enable preemption, then distribution switch 2 will
Right.
become active. But remember, preemption will not work for IP address. Preemption only work for priority.
Right.
Then you have to configure higher priority. Default priority will not work. So I want this switch 1 should be my active switch. And here I am going to do one thing. On this server switch, I am going to set up DHCP as well. Quickly, let me configure 3 pool. So that client machines can directly get IP address. DHCP enable config T interface G0/0 no cert IP address 192.168.4. This server DHCP is in VLAN 30. So IP address will be from this range 30 dot, let's say 50 255.255.255.0. exit. What will be the gateway IP address? Default gateway?
3.254.
192.168.3.254. Exit or no IP routing, host name DHCP, and then do right. Let me copy commands, and after that, sorry, pool as well. IP DHCP pool, let's say VLAN 10 network 192.168.1.0 subnet mask 255.255.255.0 and default router the virtual IP address 1.254. Exit. Similarly, I will create one pool for VLAN 24 and one for VLAN 30. So let me say here name VLAN 20. Here I am going to change in subnet and in the default gateway 2.254. IP DHCP pool VLAN 30 subnet and default gateway 3.254 and then do right. Let me copy. Is DHCP router configuration clear to everyone? We practice this many times.
Yes, sir.
Right now I am going to also put the commands on access layer switches so that PC1 will be in VLAN 10, PC2 will be in VLAN 20, and then we can test that these machines are getting IP address properly or not. So access layer switch 1, here is the command. You can see just I have configured the VTP domain name and ports are in correct VLAN, right? PC1 is in VLAN 10, PC2 is in VLAN 20. Enable and paste the command. Switch port access VLAN 10. Interface
It's
G0/2.
a spelling error.
Switch port spelling error here.
Switch port interface G03. The
The
port
second one.
switch port.
Yeah, under G03. Now keep going four lines down. Yeah, that as well. Yeah.
All good, right? Rest all are fine. Copy and let me paste again. This time all the commands are accepted. Now my PC1 is in VLAN 10. Can PC1 get IP address from the DHCP? IP DHCP. See guys, we have already covered this. Now who will troubleshoot this? Why this client machine PC1 is not able to get IP address from the DHCP server? At the same time, we are learning troubleshooting as well.
It's a different
does
VLAN. It's in a different VLAN.
Different VLAN. So MAC address
we
table. Is it learning MAC address of PC1? Switch 1 should learn the MAC address definitely. So IP. So IP all. This is the MAC address of my PC. So MAC address table, address, and yes, it is learning MAC address on 0/2 port on in which VLAN? In VLAN
10.
10 only. Great. Similarly, I can check MAC address table of distribution switch 1 as well. So MAC address, because distribution switch 1 is the active switch. That's why here I am checking MAC address table of distribution switch 1. Distribution switch 1 is also learning MAC address of
PC1.
PC1. On which port? On G0/1 port. Great. But DHCP server is in different subnet profile. You have to configure.
The subnet for VLAN 10.
You have to configure relay agent.
Relay agent, yeah.
On VLAN 10 interface, I will add one more command. IP DHCP
Helper
IP
address.
DHCP or IP helper address only. What is the
Helper
command?
address.
Yeah.
Config T interface VLAN 10 IP DHCP.
Helper address.
No, IP helper address. I think this is the command.
Yes.
Yeah.
I will share this notepad as well. Let me put the command here. What is the IP address of DHCP server?
192.
Hmm?
168.
Hmm?
3.50.
3 dot
250.
3.50.
50. Yeah.
Right. So let me copy and I will add this command on other VLAN interface as well. On VLAN 20 interface as well as on VLAN 30 interface. And from VLAN 10 interface, your DHCP server should be reachable. You can test that from distribution switch. IP helper address 192.168.3.250. And from here I can ping 192.168.3.50. Ping is not working. Now here we need to learn troubleshooting. DHCP server is not reachable from distribution switch 1. How I will troubleshoot the issue?
Space route.
So IP interface brief. All the SVS interfaces are up.
Mm-hmm.
Hmm? If I will ping like this from distribution switch 1 to DHCP server, what will be the source IP address?
Should be from VLAN 30 if you are doing the
VLAN 30
192.168.
interface IP address means
Yes.
192.168.3.3.100.
3.100.
Great. On the server, I can ping my gateway IP address from here
50.
192.168.3.254.
254.
Not working. On switch number 3 access. Okay, access layer switch 3 is not configured.
Did we grant access on the access layer switch to the server?
Access layer switch 3 is not configured. Let me do one thing. Let me copy the command of access layer switch 2 as well. And here I need to change the spelling switch port. This is access layer switch 2 configuration. Copy and paste
Have
here.
typos. We have typos.
There's one more typo switch port.
Yeah, it's misspelled in other places.
And here.
Yes.
Now okay. Copy. Accepted. Go to D switch. Sorry, access layer switch 3. On access layer 3 switch 3 also I am going to change this first. After that I will paste the command. Now okay, copy and paste it on access layer switch 3. All good.
Yeah.
Now I can try to ping and show a spanning tree. Check ports are in forwarding state or not. For which VLAN? For VLAN 10, 20 and 30. Ports are not in forwarding state. All the ports. Okay, blocking, forwarding, forwarding. Great. Now from the server I can try to ping gateway IP address. And this time ping should work. Ping is working.
Yes.
Gateway is reachable. Now from distribution switch 1 I can try to ping server. DHCP server. Ping is working. And I can try to ping from the source VLAN 10 also, that routing is working fine or not. So you can see routing is also working. Now I can take you to the client machine, and here I can try to get IP address from the DHCP, IP DHCP. Now DORA process is working, and you can see this client machine got the IP address. Okay, 192.168.1.1, and the gateway is virtual IP address ping 192.168.1.254. To which switch I am pinging? Distribution switch 1 or distribution switch 2?
Switch 1, distribution switch 1.
Distribution switch 1, right? Distribution switch 1 is my active switch, and if this distribution switch 1 will goes down, then distribution switch 2 will become active automatically. Automatically it can fail over the traffic. So ARP, here you can see the MAC address of, this is Hsrp MAC address. This is Hsrp MAC address. In the last class, if you remember, I had told you about the MAC address of Hsrp protocol. I had told you about the failover, that why failover is so important in company's network. Our first protocol was Hsrp. Yesterday I had configured Hsrp only. Hsrp stands for
Hot standby routing.
And
hot standby
routing protocol.
Redundancy.
Sorry, redundancy.
or routing.
Router protocol.
Router protocol. Okay, it works at which layer?
Layer 2.
Layer
Yesterday
3.
I had told you that as well. It works
Layer
at
3.
7
Oh,
layer.
layer.
Yeah, you did mention that.
it is layer 7 protocol.
Oh, what you're talking about
At
the
transport layer it uses TCP or UDP? It uses
C
which protocol at transport layer?
TCP.
It uses UDP. Port number 1985, I think. Yes, 1985 at transport layer. Then it is Cisco proprietary protocol. You can only enable it on Cisco devices. After that, hello time is
3 seconds.
hello time 3 seconds, and hold on time
10 seconds.
10 seconds. Very good. What is the multicast address of Hsrp? Hsrp sends their hello message on multicast address 224.0.0.2.
2.
Right? Default priority 100. Right? Track is inbuilt. A track is inbuilt for interface. You can track line interface of WAN port. Right? And if you will not configure decrement value, like whenever track will goes down, then it will decrement in priority by 10. If you will not define the value, if you want it to decrement by 20, then you can define the decrement value. But by default it decrement in priority by 10. And virtual MAC address, it uses virtual MAC address 0000.0c07.acxx, and this xx is nothing but your group number. This part is going to be fixed in the MAC address. For group number 10, it is going to use MAC address what? In hexadecimal it will use group ID, means for 10 it is going to be 0A, hexadecimal value of 10. This will be the MAC address. See, is it the same MAC address on PC? Is it the same MAC address?
Yes.
Yes, this is the
Yes.
same MAC address. This part of the MAC address, like 0000.0C, is Cisco OUI. You all know the OUI? In MAC addressing we had learned
Yes.
OUI.
The
You
first
know,
6
na,
digits
organizational
are
unique
the
identifier.
organization, yeah, the vendor
Yes.
identity.
Yes. Then
The
0,
next 6 is the
7
device identity.
and AC is Hsrp identifier. Is Hsrp identifier, and last x-axis is group ID. Which group ID? Hsrp group ID. So based on
ID.
your group ID, it can create the virtual MAC address. And you know, LAN user is going to generate ARP request message for the virtual IP address, and which switch will generate ARP reply message? Your active switch. And in the ARP response message, it is going to share this MAC address for group number 10. For other group also, you can calculate the MAC address. How many group I can create? Maximum you can create?
Um.
255.
Maximum
255.
group, very good. 0
Yeah.
to
255.
255. Great. Right?
Would that be for version 1 or 2?
Version 1.
Okay.
By
Sir,
default.
sir, I have a question on tracking. You said track is in build. Is that for, you said for LAN side or WAN side?
For LAN side, Hsrp is tracking automatically for WAN for this interface. In the Hsrp, there was one command yesterday we had used. Config T interface VLAN 10. And here I can say standby number 10 and track G1/1. So this is tracking. It will start tracking G1/1 line protocol. So this feature is inbuilt in Hsrp. Okay. And if
Okay.
you want to track ISP, then you have to create SLA. Right. But track feature is available, right, in the Hsrp. So that's why I'm saying track is inbuilt. By default, preemption is enable or disable for active router?
For active route,
Default is disabled.
disabled.
Disable. And for standby?
Enable.
Enable. Great. Right. Then in Hsrp also support authentication. You can also configure the password. Right. Then in Hsrp we have some states. Hsrp states. How many states are there? Init.
Oh,
Init means initialization, when your port will come up or when you will enable the Hsrp on VLAN interface or outer physical interface. First state of Hsrp is going to be initiate. Initiate means initialization. The second state is learning state. Right? Learn, then listen. After that, speak. Then standby and active. You already know the active and standby. Active router is the router who is going to forward all the traffic. Standby is the backup of active, and these
Active.
states are used for election. Right here in the learning, so your router or the VLAN interface is going to learn which switch is having the higher priority or higher IP address, means it will send and receive hello message. Hsrp hello message. Right, these states are not for data transfer. Only these two are for data transfer. A standby even will not send the data. Only active router is going to send data. If active will fail, standby will become active, and these routers will be only routers whose state is listening or speaking. You will not find learning state, I think. Yeah, listening directly. Listening and speaking will be only listening. It will be receiving the hello messages. When your standby will goes down, then your speaking router, the router which is in listening state, will become a standby and it will start sending hello message. In the hello message, what will be the information? In the hello message, what will be the information, and at which layer it will generate hello message? Hsrp hello. at application layer, because it is application layer protocol. The meaning of application layer protocol means what? It will generate their all messages at application layer, and in the hello message there will be some informations like anyone, what
Yeah, hello,
informations are
hello,
required?
hello, Dad. Priority.
Priority, most important, and IP address, the virtual IP address 192.168.1.254. Then timers and those all things. After that, layer 4 header. At layer 4, what will be the information? Source port and destination port. You know the Hsrp port number. Then layer 3, source IP and destination IP will be the multicast address, this one. Source MAC, destination MAC at layer 2. Okay, so this is how your Hsrp protocol works. Same thing is happening here. If you will capture the link, you will see Hsrp hello message, and in the hello message you will find these information, all the headers at transport layer, network layer, data link layer. Inside that you can check the fields, like you will find the same multicast MAC address, you will find the port number, destination port number. Here, if I want preemption should work between distribution switch 1 and distribution switch 2, I can configure priority, higher priority, and I want distribution switch 1 should be always active for all the VLANs, for VLAN 10, 20 and 30. Can I achieve load balancing for VLANs? No. With the help of single group you can't achieve load balancing. If you want to achieve load balancing, you can create multiple group. You know, with the help of multiple group how we can achieve load balancing. Yes, na? Here for all VLAN I want VLAN 10, VLAN 20 and 30. Interface range VLAN.
VLAN spelling is wrong.
VLAN spelling is not correct.
Okay, 10, 20 and 30. 10, 20 and 30.
Maybe the range should not be there.
VLAN 20 and VLAN 30. Standby number 10, priority 150, let's suppose. And on distribution switch 2, I can configure priority do show history. I can configure lower priority there. On distribution switch 2, I am going to configure priority let's suppose 130 or 140. Now if I will enable the preemption, it will work, right? Automatically distribution switch 2 will become active, not distribution switch 2, because now I have configured the higher priority here. But you can enable the preemption, standby number 10 and preempt. On distribution switch 2 also standby number 10 and preempt. And regarding tracking, we have already seen in the last class. Here if you want to configure the complete lab, just copy the commands of router, just see the IP addresses only, IP address and NAT configuration. I can copy and paste.
So I have a question.
Wait a minute.
Okay.
I will allow you to ask. Commands to configure one IP addresses, default or towards internet, and access list, and then NAT. The same commands. Yesterday we had seen. Let me access router 1 and let me paste the command. Enable and paste. What happened? Interface, okay. Enable config T and then paste the command. Access list is not working because exit is here. Let me remove this exit and then let me add the commands. Go to R1, paste the command and then remove the console if you don't want. I can also add the host name R1, right? On R2, here is my command. Again, here I need to remove this exit, copy IP addresses and ACL and NAT. Only 3 types of configurations are there on the router. If you need complete lab, then you can configure routers. Otherwise, you can skip this configuration. Config t host name R,
R2.
right? Let me save the configuration as well so that later we can use R1. Save it. ISP configurations are also there. Yeah. On the ISP router also you can see only IP addresses are configured. Let me copy it and let's paste it on ISP1. Now LAN users can access internet as well. ISP1, save and close the console. ISP2, enable config t and copy and
What are
paste.
you looking for?
Can LAN users access internet? Can PC1 ping 8.8.8? Ping 8.8.8.8. Ping 8.8.8. What error I am getting? Destination host unreachable. It mean what? It mean my default gateway don't have route. So IP
Doesn't have
route.
route.
Default route is not there, you can see, right? And I think routers also don't have your internal LAN subnet. So IP route. Only connected routes are there. You can do one thing, you can enable any routing protocol interface range G0/0 and G0/1 IP OSPF 1 area 0. Do history. Do so history. Let me copy the command and let me paste it on router 2. Not showing, no problem. I can run manually. Interface range G0/0 and G0/1 IP OSPF 1 area 0. Don't worry about the OSPF configuration because we will learn it. Here again I am going to update the configuration and now I can close the console if you don't want to verify, but you have to enable OSPF on distribution switches as well. Go to this switch 1 and very quickly let me enable OSPF. Interface range G1/1 and G1/2 IP OSPF 1 area 0. Do so history. If I am using same interface, no. On distribution switch 2 I am using different interface, so interface range G1/0 and G1/2 here. IP OSPF 1 area 0. Now you will have OSPF neighborship. Here you can see between distribution switch and router number 1. Now you can advertise your LAN prefixes. Interface range VLAN 10, VLAN 20 and VLAN 30 IP OSPF 1 area 0 and do so history. Copy and let me paste these commands on distribution switch 2 as well. All good. Now if you will check router number 1 routing table, then you will have all the LAN subnet. So IP route OSPF. Here you can see 192.168.1.0, 2.0 and 3.0. So now LAN user can ping internet as well. Go to PC1 and ping 8.8.8. Still ping is not working because default route is still not there in the routing table. Just do one thing, go to router number 1 and I can say router OSPF 1 and default information originate always. Do so history. Why on the router commands are not showing, don't know. Router OSPF 1 default information originate and always. That's it. Now go to PC1 and ping. See, 8.8.8 is reachable. So this is going to be my complete configuration. So simple. You can see, right? You know all the commands, all the configurations. And here is my topic, Hsrp. Hsrp is also running well. Just I want to track, let's say router 1 IP address or ISP IP address I can track. If I want to track this line protocol of this interface, you can track. But my concern is over here in the LAN. PC1, okay, let me close these all console. It is not required and it is taking some time. See, now we can verify. Similarly, like we had verified on the router, similarly here also I can verify from PC1. I can ping 8.8.8.8. Ping is working. Great. I can trace route from PC number 1 to see from where traffic is going. Trace and 8.8.8.8, and you can see 192.168.1.100. Where you have configured this IP address, guys?
Distribution switch
Right.
1.
Correct. Here you will not discover the virtual gateway. Here you will discover the physical IP address. Traffic is going to distribution switch 1.
And
Distribution switch
it
1 is
goes to
forwarding to router number 1,
the
and router 1 is
1
forwarding to
going to
ISP 1.
ISP.
If I am keep pinging, ping 8.8.8, and at this time, if distribution switch 1 will goes down, where is ping? Here it is. And let me say interface VLAN 10 and shut down. Like this you can test here. Now it will perform failover. Now you can see state is moved from active to init. Now distribution switch 2 will become your active router, and now you can see again ping started working. Now which switch is the active switch? So standby brief. Now you can see this switch is in init state for VLAN 10. For VLAN 20 and 30, this switch is the active switch. But for VLAN 10, distribution switch 2 is the active switch. And for VLAN 2030, distribution switch 2 is the standby switch. Again, when VLAN 10 interface will come up, no cert, this switch will become active switch. Hope Hsrp protocol is clear to all of you. Let me know if yes.
Yes, it is.
Can I move to VRRP now?
Sir, I want to deviate small from the Hsrp.
Go ahead.
From the topology you show us. What about if I have a web server in one of these access switch, then this web server can be, I have an application there, then I want the public to access that application.
For that you will configure a static NAT here on router. You will configure a static NAT, right? You can configure directly public IP address on the server, and you can share that public IP address with outside user, or you can configure a static NAT here. There also you will just map the static IP address of your web server with public IP address here with the help of a static NAT, and you will distribute that public IP address with outside user, or through DNS you can distribute the domain name, and on the internet DNS will
Yeah,
resolve that domain name.
I really want us to simulate one of that lab.
Yeah, later we will have that lab in the netting.
Okay.
Yeah, that's a different topic in
That is
itself.
different topic. Here just I have configured the NAT for only one reason, just to make the lab realistic, so that you can understand like how LAN users are accessing the internet when the LAN interface will goes down, how failover will work. At the same time, when any WAN interface or ISP will goes down, then also how it is going to perform failover. This is the reason why I have configured NAT here, nothing else.
Yeah, I know, right? Okay.
So,
Okay, Prabhu.
Go ahead.
So what will
before we go further, I have a question. When you did troubleshooting, and when you ping the server from the distribution switch 2,
Okay.
you said which source address the distribution switch will take, and you said VLAN 30, I think.
Correct.
How does it know to take VLAN 30?
It will
Yeah.
compare this
when
IP
you-
address with routing table. So IP route 192.168.3.50. It will get to know that exit interface is
So it will take source from VLAN 30.
correct.
Okay. Okay, thank you.
Welcome. Anything else?
Okay,
So
Prafu.
what will be the
Yeah.
default gateway of the client PC
Sorry?
when we configure HSRP? What will be the default gateway when we
Default gateway is
configure
the
HSRP?
virtual IP address.
Virtual IP address. Okay.
The virtual IP address which I have configured. So run interface VLAN 30. This is the virtual IP address for VLAN 30. For VLAN 10, 20, 30, you can check. This will be the gateway, right? I have configured this gateway in my DHCP, if you remember.
So how come if the failover happens to choose the other switches
Both the switches are
gateway?
exchanging hello message. Hsrp hello message.
Oh, so both the IP will be shared
Like when
from both.
distribution switch 1 will goes down, distribution switch 2 will not receive hello message. Correct?
Okay.
It will not receive hello message. That means I am the active switch. Right? In the election, this switch will win then. If it is not receiving superior BPDU, if a switch is not receiving superior BPDU, then that switch will become root bridge, right? Similarly
Yeah.
here, if a switch is not receiving superior Hsrp hello message, that switch will become active switch. If both the switches are up, let's suppose both the switches are up, but these links are down. In that case, both the switches will become active switch. 1 minute, brother. After that, you can ask question, Haruna. Okay?
Okay. So Prafu, can I go ahead?
Yes, Haruna. Please ask now. What was your question?
Okay, I think he's not ready. That I want to ask. So Prafu, you mentioned that preempt is disabled on the active router,
For the
and then
active
it's
router.
enabled. Yes, and it's enabled by default on the standby.
For the standby.
And so if we had not configured preempt, it will still have worked because it is enabled, right?
Still, you have to wait.
No, I think you got my question wrong. I'm asking, can you please bring up your configuration? The notepad you had a configuration on.
First of all, let me tell you this thing clearly. What I said, let's suppose I have 3 router R1, R2 and R3. Okay, all are connected with switch. Here I am running Hsrp protocol. So all the switches are going to exchange hello message. Based on hello message, one router will become active router. The router who has higher IP address because priority is same. Okay, so let's suppose here IP address is 1.1, 1.2, 1.3. This router will become active router because this router has higher IP address. And which router will become a standby router? Router number 2. Now here I have changed the IP address. I have configured 1.10 or 100. Will R1 become active? No, because preemption is not enabled. Will R1 become a standby? Yes, R1 will become a standby because preemption is enabled for standby. So any router who has higher IP address can become a standby router but not active router because of preemption. What happened? Let's suppose here this is my IP address and now I have enabled Hsrp on router number 1. I have only enabled Hsrp on router number 1, not on other router 1.1, 1.2 and 1.3. Or here I have configured priority, doesn't matter IP address, leave IP. Here I have configured priority 110, here I have configured priority 109, here I have configured priority 108. So router 1 should be my active router, but here on router number 3 I have enabled Hsrp. Great. Enable this router became active router, right? Because I didn't enable HSRP on all the router within 10 seconds. Because after enabling HSRP, router will wait for 10 seconds for election. Within 10 seconds, if router will not receive superior HSRP hello message, then that router will become active router. So here on router number 2, I have not enabled HSRP. On router number 1 also not enable. That's why router 1 became active router. Now I have enabled HSRP on router number 2. Will router 2 become active router? Answer no. Why? Because active router is already elected and preemption is disabled.
Bro, whatever the router gets configured first, that becomes the active router, regardless of the priority set. And then
Understood?
yeah, and
Haruna,
then it remains active. It remains active. It doesn't matter if someone has higher priority until you configure preemption.
and see for a standby. Now I have enabled HSRP on router number 1. HSRP. So router 1 has higher priority than router number 2. Even higher priority than router number 3. But router number 1 cannot become active because preemption is disabled for active router. Can router 1 become a standby router? Yes, it can become a standby router because preemption is enabled for standby. So this router, earlier router 2 was standby, now router 1 will become your standby. It is like that. Now, if you have any question, please ask here.
Thanks for the clarity.
Clear?
Yes.
Great. So,
Sir, I have one question.
go ahead.
In this topology, the just distribution switch one and two between two, there's link right in the port channel maybe. So the hello message, XHRP hello message exchanging by through this link or through the access layer switch. The how they exchanging the hello packet, which link is the
Hsrp
responsible for
hello
that?
message is the multicast message. It will send from all the trunk link where VLAN 10, 20, 30 are allowed. Over all the trunk link.
Over all the trunk links.
Correct.
Okay. So can I specify means what is can I specify this the two link for the responsible for the multiple traffic other than two link other link will not participate for the multicast hello exchange. Can we do that thing?
Here you
Suppose
can't do
there
that.
is
No.
okay, 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 sir. And for the load balancing between the SSRP between the two switches. So which condition we need to fulfill there?
In this condition also, I want, let's say, load balancing. I want distribution switch 1 should be my active switch for VLAN 10, 20, and distribution switch 2 should be active switch for VLAN 30. So I want to forward
Okay.
all VLAN 10, 20 traffic via distribution switch 1 and VLAN 30 traffic, like VLAN 30 is for servers. So servers traffic should go via distribution switch 2.
Okay, so thank you. And the last question is that whenever the one switch is for the active
Okay.
for the all the traffic and the other switch for the standby, so what is the condition in the what is the status of the all the ports of the standby switches? Is the listening mode or any or is
Standby
there any
mode.
way? So if I go for the status of this port,
No,
so
that will be up
can is
only.
okay, okay. There
Ports
is no
are,
mentioning for that. Okay,
no, no.
okay.
Port status and line protocol. Admin status and line protocol both are up. So standby brief. You can see this switch is the standby switch. Here you can see the virtual IP address. Standby is local. Virtual IP address is this one. And active router IP address is this one. Distribution switch 1. But show interface status. All the interfaces are showing connected.
Okay, so is there any interface and the switch port? If I mention that, is there description? Is the SHRP protocol is enabled or standby? Is there anything information mentioned there?
So interface G0/1 switch port.
Yes. Is there any anything denote that if this is participate or HSRP or something we can see here?
No, you can't see here. Nothing is there from
Okay.
the
Okay,
HSRP.
sir. Thank you. Thank you. Thank you, sir.
Anything else? And here I can write one more thing, that is election. For election, it is going to check highest priority first and then highest physical IP address or physical interface IP address, you can say. This is election of Hsrp. Now the second protocol is VRRP.
Yeah.
The difference between Hsrp and VRRP is only one thing, that Hsrp is a Cisco proprietary protocol and VRRP is a open standard protocol. Both works exactly same. VRRP stands for Virtual Router Redundancy Protocol. Redundancy protocol. It is open standard protocol, means you can run on Cisco as well as on non-Cisco devices. If you have, let's say, distribution switch 1 is Cisco switch, distribution switch 2 is non-Cisco switch, you can't configure Hsrp here, you have to configure Glbp. And there is some difference in hello time also. Hello time is 1 second by default, right? In Hsrp also you can configure 1 second, right, for better performance, like quickly. Sometime you have seen that one failover was happening at that time, PC some traffic was getting dropped, 5 ICMP packet round, it was taking 10 seconds. So through timer you can manage that. Let me show you here. See, PC1, it is ping is working, and I think distribution switch 1 is the active switch. So standby brief, yes, this switch is the active switch, local switch. If I will down interface VLAN 10 shutdown, you can see 1 2 3 4 5 packet got dropped. If you want to reduce this, you can manipulate with Hsrp timer. VRRP has by default 1 second. Hello time means it is going to send hello message after every 1 second, and hold on time is 3 seconds. At which layer VRRP works? Here is another difference. It is the layer
Layer 3.
3 protocol. Then Praful, tell me the port number. If layer 7, then protocol or service at transport layer, TCP or UDP, and port number. If it is a layer 3 protocol, then tell me the protocol number. So protocol number of VRRP is 112, and the multicast address is 224.0.0.18, right? The name of active router is master here. Name of active router is master in VRRP. So one router will become master router, and only master router will send hello message. In Hsrp, standby is also sending hello message. In VRRP, only master router will be sending hello message, like your root bridge. Once root bridge election will happen, after that only root bridge will be sending BPDU. Non-root bridge switches will not send any configuration BPDU. So after election, only master's router will send hello message, and preemption is by default enable in VRRP. And after that, it uses MAC address 0000.005e
Excuse me, there is a noise.
00XX, right? So till here MAC address is similar, and this XX is nothing but group number. Election criteria is also same, highest. Guys, there is noise, please put yourself on mute if there is noise from your side.
Gideon Ante.
Higher priority, after that highest IP address. exactly same. Default priority is also 100. Default priority is 100. I can show you the configuration. Let me do one thing. From distribution switch 1 and 2, I am going to remove Hsrp configuration, interface range G, not G, VLAN 10, VLAN 20, and VLAN 30. No standby, group number 10. Do so history, copy the command and run command on distribution switch 2 as well. Before configuring Hsrp, Vrrp on distribution switches, configure on router. That's why lab in GNS3 is also on. Here also we can test first. That is good to understand. Now you can see Hsrp is removed. Now let me configure Vrrp. To configure Vrrp on distribution switch 1 first, distribution switch 2, distribution switch 2 and distribution switch 1. Okay, command is going to be Vrrp and then group number 10 and after that IP address 192.168.1.254. Now if you will check LAN user, so ping is working. Ping is still working, guys. So ARP, is it the Hsrp MAC address?
Yes, it is.
Still I am
Yes.
able to ping
Yes,
8.8.8. How ping is working? Anyone? Is that means that MAC address is still active?
yeah.
Is Hsrp still enabled on distribution switch 1? So standby brief, no. So run interface VLAN 10. Command is not there. I think on distribution switch 2 it is still enabled. So standby brief, no. So run interface VLAN 10. And one more thing is there, like in case of failover, sometime interview is asking this question. During failover, when distribution switch 1 will goes down or the VLAN 10 interface will goes down, MAC address will not change, the virtual MAC address. Switch 2 will start using this MAC address, means switch 2 will start replying with this MAC address. MAC address will be same. Active switch will be using this MAC address. So Hsrp is not enabled on any switch. So let me check gateway once. So IP all, gateway IP address is the virtual IP address and ARP is empty now. Now if you will check ping, then you can see ping is not working because now PC cannot resolve. Now PC cannot resolve MAC address. What was happening earlier? Switch is maintaining MAC address table, so entry was already there. Right? PC was generating traffic for internet 8.8.8 source IP address of PC, destination IP 8.8.8 source MAC address of PC, destination MAC, the Hsrp virtual MAC address. PC was sending traffic to switch 1. Switch 1 will check MAC address table. It will compare destination IP with MAC address table. It will find the exit interface. It will forward traffic to distribution switch 1, and distribution switch 1 was doing the routing. But once ARP table is clear on the PC, then you can see ping is not working now. Now again, let me take you to distribution switch 1, and now I am going to enable Vrrp protocol. So command is Vrrp group number 10 and IP 192.168. Sorry, I will not run this command on all these interfaces. Interface VLAN 10, Vrrp group number 10 and IP 192.168.1. Then VLAN 20 IP address, VLAN 30 IP address 3.254. Do so history, Let me copy the command from here and let me paste it on distribution switch 2. Okay, now let's verify. You can see this switch is the backup switch. Backup means standby in Hsrp. The name is changed. Standby switch will become backup switch here and active switch will become master switch here. On distribution switch 1, you can see this switch is the master switch. Command verification command is show vrrp. So vrrp. Here you can see. Preemption enable, default priority, master router IP address. Master router is router 2, distribution switch 2, not distribution switch 1. Now check vrrp, and this is backup switch. This is backup switch for VLAN 20 also. This is backup switch for VLAN 30 also, because preemption is enabled by default, right? And distribution switch 2 has higher IP address, master, master, master. Distribution switch 2 is the master for all the VLANs. So vrrp. VLAN 10, group number 10, state is master, virtual IP address is 1.254, virtual MAC address, right? Group number, and after that you can see the same MAC address, right? This one. Then preemption is enabled, priority is 100, master router IP address is local. Okay. Then I want distribution switch 1 should be my master switch. You will change the priority. Let me do that as well. Config T, and now I am going to use range command so that I can configure higher priority on all the interfaces simultaneously. 10, not standby, vrrp. vrrp command will start with vrrp, then group number, and after that you can see you can manipulate the timer, you can configure priority, you can enable or disable preempt, you can also configure tracking here, exactly similar like Hsrp. So here I want to change priority 100 and let's say 20. Now distribution switch 1 will become master switch soon. You can see the state. Okay, and on distribution switch 2.
So, sir, in VRRP, preemption is enabled by default for both IP and priority.
Standby means for the backup as well as for the active.
Sorry, yeah, for active and okay, as opposed to Hsrp. Okay, got
Right,
it. Thank you.
If you want to use tracking, similarly you will use tracking in vrrp as well. So vrrp and Hsrp, both protocols are exactly interface VLAN 10. Both the protocols are exactly same. One is Cisco proprietary, another one is open standard. But you know Cisco always come up with load balancing. When we come up with CST, Cisco design PVST. When open standard for design RSTP, then Cisco design RPBST, right? So first Cisco come up with Hsrp and then Glbp for load balancing. In Hsrp also you can achieve load balancing, but you have to create multiple group, right? Routers will generate multiple hello messages, that is going to use more CPU. So within the group, can I achieve load balancing? Yes, within the group also we can achieve load balancing. For that we have third protocol. But tracking is going to be exactly same. vrrp number 10 and then track, and after that tell me which track number is, let's say 10, and in track number 10 I can also call IPSLA. You know this. We can also call IPSLA in track number 10, or that then decrement in priority by let's say 10. So here what priority I have configured? What is the priority?
120.
120.
Yeah.
So, and on distribution switch 2 it's 100. So I'm going to decrement in priority by, let's say, 30. So this switch will become what? Track number 10, decrement in priority by
90.
30. So after decrement, priority will become 30 here and failover will
90.
happen. But here track number track command is not available. I think it is available on your router. Let me see. On the interface also directly we can track. No need to configure IPSLA here for this scenario. Configure T interface F0/0 and track. No. Okay, then you can do one more thing. Track is not available on the interface. Then here on distribution switch 1 I have used track number 10. Let me run the command in global config mode. Track number 10 and interface G1/1 line protocol. Just I said track number 10 to track line protocol of G1/1. All good. So Vrrp brief. You can see this router is the master router, and if G1/1 will goes down, and what is the priority? 120. Config T interface G1/1, let's say shut down. Now you can see line protocol is down. That's why your track state is down, and when track will goes down, it will decrement in priority by 30. That's why this switch is backup switch. So Vrrp brief. Now you can see what is the priority for VLAN 10? 90. So tracking is exactly same. You can also configure IPSLA like yesterday we had configured. Now I am going to up this interface again. No shutdown. Again this switch will track is up. Now you can see here track is up, and when track is up, then this switch will become master switch. Any question in Vrrp, guys?
Sir, is it possible to configure VRP on the router and HSRP on the switch?
No, both the protocols are not compatible with each other. Both router you have to configure same Hsrp or Vrrp only. Like if you have one router and one switch, how you will configure? Where is the router?
Now, what I'm saying is that, like this topology, you have two router and two switch. I want
Where is two
availability for this distribution switch.
Here you will configure Hsrp.
Okay. And
Here do you
here
want to
also
configure Hsrp here?
yes, exactly.
Hsrp for LAN user, sir. Hsrp is a or Vrrp is a gateway redundancy protocol. You will configure for gateway.
Okay.
Hsrp is running here in this section, not on this router. So Hsrp and Vrrp both are same. Now the very interesting protocol is GLBP. Again GLBP is Cisco proprietary or open standard?
Cisco proprietary.
Right. For on Cisco devices you will configure GLBP only. Gateway load balancing protocol. Gateway load balancing protocol. By default or in a single group, Hsrp and Vrrp can not perform load balancing. Load balancing is not possible in case of Hsrp and Vrrp for single group. That's why we come up with GLBP. Right? In Hsrp and Vrrp you have to create multiple group. but GLBP can perform load balancing. GLBP can perform load balancing. Question is how powerful, right? And about the timers, guys, hello time is again 3 seconds, right? You can check these all things in book as well. Again, it is application layer protocol uses port number 3 and 3 time 2. Multicast address 224.0.0. I think 102. You can check once. Priority is 100. Hold on time 10 second. Hello time 3 second. A port number clear MAC array. Sorry, multicast address priority. And here we have one more thing, that is wait. I will discuss that. Preemption is again by default disable. By default it is going to work exactly like Hsrp. If you have the single gateway, then single router will be the active router only. But when we have multiple gateway, then two types of router election will happen in GLBP. Let's suppose R1, R2 and R3. Here in Hsrp and Vrrp, election is happening for which router? For active router only. Which router will become active router? But here definitely you will have one active router, but that is not going to forward the traffic. One router will become here AVG. AVG stands for active virtual gateway. And all the router, whatever routers you have, like maximum 4 router can become AVF, who is going to actually forward the user traffic. AVF, active virtual forwarding or forwarder, something like this, either forwarding or forwarder. These routers are connected with switch. Below switch I have LAN devices. Understand this, on Cisco devices you will configure GLBP only, and I am going to show you the configuration as well. But before that, understand working how it can perform load balancing. Switch 1, and let me say some users: PC1, PC2 and PC. Okay, so let's suppose here I have enabled protocol GLBP, and this is my AVG, right? For the AVG, router 1 is the active router, router 3 is the standby router, because preemption is not enabled for active router again. So even router number 3 has higher IP address, or let's suppose here I have configured higher priority on router number 1. So that's why router 1 is my active router. Router 3 is the standby router who has higher IP address. Priority between router 2 and router 3 is same. And this router is in listen state. Similar like Hsrp. Similar like Hsrp. Router 1 is the active router, router 2 is in listening state, and router 3 is the standby router. Sorry, standby router, AVG. But you know, AVG is going to store the information of AVF, the forwarder, who is going to actually forward the user data. Once you will enable GLBP on router 1. Router 1 will become active router for ABG. And if you will enable GLBP on all the router, on every router within 10 seconds, then R3 will become active router for ABG, the router which has higher IP address, if we have not configured the priority. After that, ABG is going to store the information of AVF. AVF1. How many routers are there? In my group 3. So 3 AVF will be there. AVF1, AVF1, AVF2 and AVF3. Right? Let's suppose for AVF1, router 1 is the active router. One router will become active for AVF1, one router will become AVF4, router 2 like for AVF2, and one router will become active router for AVF3. AVF3 like this. GLBP is going to work. You will understand more better way. Don't worry. Let's suppose the PC1 is using IP address 192.168.1.1 and the virtual IP address is 192.168.1.254, the gateway. PC2 is using IP.2, PC3 is using IP.3. When PC number 1 will generate ARP request message, when PC1 will generate ARP request message, then my AVG is going to share the MAC address of AVF1. It is going to share the MAC address of active router, which is the active router for AVF1. First user will get the MAC address of router 1. One second user PC2 is going to generate ARP request message for same virtual IP address. Then AVG is going to share the MAC address of AVF2, the active router of AVF2. When third user will generate ARP request message for the same virtual IP address, AVG is going to share MAC address of active router for AVF3. Okay, so when end device is going to generate ARP request message for the virtual gateway IP address, AVG active for AVG will reply, and in the reply it will share the MAC address of active router for AVF1. For first request, active router of AVF1. For second request, active router of AVF2. For third request, active router of AVF3. Again for fourth client machine, active router of AVF1. Right, so fourth PC and first PC will send traffic through router number 1, second PC will send traffic through router number 2, third PC will send request message from router number 3. And how many router can be there in the AVF in one? How many AVF can be there in one AVG? 4. 4 AVF can be there in one AVG. Let me enable this, then I can make you understand clearly. Access R1. First I am going to enable here on router, then you can enable on distribution switch as well. Right now I don't think any Hsrp configuration is there, so run interface F0/0. Okay, it is configured, group number is 10. Let me say interface F0/0, no standby, number 10, and do so history. Copy, paste on R1 and paste on R2 as well. And let's enable GLBP now. Config T, interface F0/0, GLBP, group number 10 and IP address 192.168 dot. What is the IP address on physical interface here? 1.1, 1.2, 1.3. So let me do one thing. Let me create virtual gateway what? GLBP group number 10 IP 192.168.1.100 or 254 only. Let's say last IP address 254. Do so. History. Preemption is disabled. If I will wait for 10 seconds, then order 1 will be my AVG. If I will configure GLBP on all the router within 10 seconds, then order 3 will become AVG. Here I have enabled the GLBP and you can see this router is the active router. So GLBP and here you can see how many forwarder is there. AVF only one forwarder is there. That means only one router is there in this group. For this AVG you have only one router. Right now only one forwarder is there. All the traffic will go through this forwarder and you can see the forwarder information as well here. Okay, let me and rest all the things are exactly same. State active, you can see the virtual IP address, hello time, hold on time, next hello due. Okay, redirect preemption is disabled, active router is the local, standby is unknown, priority is 100, wait is for load balancing. I will discuss this soon, right? And group forwarder, let me configure R2 config T interface G not GF 0/0 GLBP number 10 IP 192.168.1.254. Now on order number 1, check the forwarder. Once it will receive the GLBP hello message, it will add one more forwarder. Right now only one forwarder is there. Now there are two forwarder, one forwarder is active. Soon both forwarder will become active. Now you can see this forwarder is in listening state. Soon it will come in active state, right? All the forwarder is going to be active. All the forwarder is going to be active because what I told you, AVF is active virtual forwarder and all the router in the group will be forwarding the traffic. Active virtual gateway is going to reply to the MAC address, that's it. And it will be replying the MAC address of forwarder. Now you can see there are two forwarder active. This forwarder is in listening state. Wait, till then I am configuring R3 as well. Interface F0/0 GLBP number 10 IP 192.1.254 and so GLBP brief fast ethernet 0/0 local is the standby. Okay, it will take some time, 10 seconds. Now how many forwarders are there? How many forwarders? 3 forwarders.
3.
And how many AVG? Only one. On other router also you can check. So GLBP. Here you can see a state for GLBP. AVG is. This is AVG
Listening.
information. This is AVG information, and these are forwarder information. So this order is in listening state for AVG, and order 3 so GLBP. This order is standby for AVG, but all the routers are active router for AVF. You can see router number 3 is the active router for AVF 3. See on router number 1 now very clearly. So GLBP. Router 1 is going to forward traffic of first user. Let's say first user has generated the ARP request message. So there are 3 forwarder, and this router is the active for 1 forwarder. For this forwarder, this is active. Router number 2, so GLBP. Router number 2, 3 forwarders are there, and this router is active for 1, and forwarder number 2, this is active. Router number 2 is active for forwarder 2, AVF 2, and router 3 is in listening state. Router number 3. Router number 3, again 3 AVF and 1 is active. This router is active for AVF 3. Router number 2 is in listening for AVF 2. Router number 1 is in listening for AVF 3. Go to PC LAN user. PC1 IP 192.168.1.10/24 and gateway 192.168.1.254. If I will ping to 8.8.8, will ping work? Let me see. Ping is working. Let me trace 8.8.8.8. Traffic is going through which router?
Router 1.
Going through router 1.
This is not the console of this PC. This is EVNG virtual machine console. Let me access properly. Here I got IP 192.168.1.10/24 and 192.168.1.254. You can test the connectivity first. Ping 8.8.8. If yesterday configuration is there, then ping will work, but I don't think yesterday configuration is available. So IP route, default route is there, 1.1.2. Yes, ping 8.8.8 or ping 1.1.2. Ping working. Ping 8.8.8. Ping is not working to 8.8.8. So IP interface brief. Loopback interface is down. Why loopback interface is down? Loopback should be up. Interface loopback 1, no, shutdown. Yeah. Now go to PC1, close the ISP, PC1 and ping. Ping is working, and now let me trace 8.8.8.8. Where traffic is going? On router number 1. Let me access PC2. IP 192.168.1.20, let's say /24 and 192.168.1.254. Let me trace route. Trace 8.8.8.8. Where your traffic is going?
To router 1.
Router 2.
Router 2, yes, 1 or 2.
Right? So second PC, like another client, second client is generating ARP request. AVF is sharing the MAC address of AVG is sharing the MAC address of active router for AVF 2. And when this machine PC3 will generate request, then AVG will share the MAC address of active router for AVF 3, 192.168.1.30/24, 192.168.1.254. Let me trace route from here. Trace 8.8.8.8. You can see traffic is going to
3.
3.
Router 3.
And again, if I will change the IP address here, let's say 40, I have configured 40, and if I will generate traffic for internet, then traffic will go through which router? Active for AVF1, right? Active for AVF1 is R1, na? So traffic will go through R1. It should go through R1, I think.
No, it's not R1.
It is going through R3 only.
R3, yeah. It's not
Right.
R1.
So I think ARP table is still updated. Even when we are changing the IP address, ARP table is not getting update. If I can clear ARP table somehow, clear ARP. Okay, clear ARP. And now if I will generate traffic, trace 8.8.8, you can see where it is going.
R1.
R1. Again, if I will clear ARP and generate the traffic, AVF 2. Active router for AVF to router number 2. Again, if I will clear and trace route, then going to R3. Again, if I will clear and send traffic, it will go to router number 1. Again, clear ARP and send router 2. Clear ARP and send R3. Right? So in the GLBP, you can achieve load balancing for single group. Now you can enable GLBP on distribution switch as well. How load balancing is happening?
ABF.
Using round robin.
Yes, using round robin. That is default load balancing algorithm. If you want to distribute the traffic, that is not in our syllabus, but then also if you want to distribute the traffic for AVF, like AVF1 should send more traffic, let's say 70% traffic. Right now load balancing algorithm is 1:1:1. Equally it is distributing traffic. If you want to distribute the traffic not like this, more traffic through AVF1 and less traffic from AVF2 and 3, then you can use weighted here. So GLBP, in the GLBP you can see weight value. What is the weight value? 100, right? You can change the load balancing algorithm as well as you can change the load balancing algorithm F0/0 GLBP question mark group number 10 question mark here load balancing, and you will have 3 load balancing algorithm here: round robin, weighted, and host dependent. Host dependent, round robin, and weighted. So weighted, and here I can define the weighted load balancing algorithm, and after this I can configure the weight value. Here I can configure weight value, higher weight value for ABF1, because this router is the active router for ABF1. By default load balancing algorithm is 1:1:1. Let's suppose now I want my load balancing like this: 4, 2, and 1. So we can do it through weight value. Now on the router number 1 I can configure what? Weight 40, on router number 2 20, and on router number 3 10. I can configure load balancing ratio like this: weight value 40, 20, and 10. It is going to distribute traffic like this. If you have understood, very good. Not understood, no problem. GLBP should be clear. And some more thing. So GLBP and brief. Here also you can check that which router is the active router. C, group number 10, priority 100, and here is this is AVG information, and these are forwarder information. So you can see this router, local router, is the active router for forwarder 1. This is troubleshooting command. This is active router for forwarder 2. So who is using this IP address? Whose IP address it is? Router 2.
2.
It means what? Router 2 is the active router for forwarder to AVF2, and 192.1.3 is the active router for AVF3, right? Third forwarder is router number 2 3, second forwarder is router 2, and first forwarder is local, means router number 1. And here is the information of AVG. So GLBP works on AVG and AVF. Right? Only introduction is the part of our course of GLBP, Hsrp and Vrrp. Like you have learned all the things about Hsrp, Vrrp. Even GLBP is also same protocol. The message exchange is going to be exactly same. Election is exactly same. Like for ABG, election is exactly same. But here AVG is selecting and storing the information of AVF also. If I have 4 routers, then there will be 4 forwarders to distribute the traffic, and AVG is only responsible to distributing traffic between multiple AVF, between multiple forwarders. Okay, so here you can test, and here also you can enable on distribution switch 1 interface range, VLAN 10, VLAN 20, and VLAN 30. Am I running any standby command? So run interface VLAN 10. Which protocol is running? VRRP. So say no, VRRP group number 10. Remove it. And GLBP number 10 IP 192.168.1.254. What it's saying? Address 192.168.1.254 in group number 10, interface VLAN 10, interface range fell for VLAN 20. So for VLAN 20, I think another protocol is running. Do so run interface VLAN 20. For VLAN 20, it is not enabled. Interface VLAN 20, and then okay, sorry, IP address. Actually, it was my mistake. So for VLAN 20, IP should be 2.254, not 1.254. So just let's test for VLAN 10 only. Go to distribution switch 2, and here also test it for VLAN 10, interface VLAN 10, and do so run interface VLAN number 10. No any command is running, so say GLBP number 10 IP 19.
VRP is running.
Where is the okay? No. So here I will have one AVG and 2 forwarder AVF. So GLBP. If you want to practice more about FHRP protocol, then you can try to configure load balancing based on VLAN in Hsrp and Vrrp as well. You can create 2 groups, group 10 and 20. One router will be active router for VLAN 10, one router will be active for VLAN 20, for group number 20. Right, here you can see on the distribution switch also we have same output, 2 forwarder. This router is the active router for forwarder 1. For forwarder 2, this router is in listening state, and distribution switch 2 is active for forwarder 2, so GLBP. Right, forwarder 1 is in listening state and forwarder 2 active. If you want to learn more about GLBP, You can find video on my YouTube channel as well. Clear everyone? This is all about gateway high availability protocol or first hop redundancy protocol, or the technology used to create single virtual gateway through multiple physical gateway IP addresses. Okay, but I think you guys are not configuring labs, so no logic, I think.
Raful, Raful,
Yes,
so are you going to send this configuration now?
which configuration, sir?
The one that we just done. This one.
This one?
Yeah, yes, sir.
Okay, let me, but some commands were was missing there, or it can be incorrect as well. You can check that. Okay.
Yeah, you also send the video so that we can follow with the video
Yeah,
in doing
definitely video will
the
be
lab.
shared. Definitely video will be. Sir, please share the configuration file and topology file after the class. Yes, here. Anything else? Now I am going to delete this lab because we will not use in future classes.
What is the MAC address for this GLP?
MAC address for GLBP. So here I have not write down the MAC address for GLBP
No, sir.
because I am not remember GLBP MAC address format. Here it is. And XXYY is what? See, where XX is the 2-digit hexadecimal GLBP group number, and YY is the 2-digit hexadecimal number of AVF. Got it? Here you can verify that as well. Let me write down the MAC address format for GLBP, and here also this is the format. Okay, this is group number, and this is AVF.
So which one is most commonly used in real time?
On Cisco devices, GLBP. See here, if I am going to verify the MAC address of, let's say, forwarder 1, so GLBP, this is what 10 group number, and this is what forwarder number, AVF2. This is group number and this is forwarder number, AVF3. Group number and forwarder number. On the PC, ARP. ARP is not there. Let me ping or trace route. So traffic is going through which router? How I can verify that? Through MAC address also you can verify that. Group number and forwarder 1. Which router is the forwarder 1? Router 1. And clear ARP. Clear ARP and then trace route. Now traffic is going through router number 2 and ARP. Now you can see the MAC address. MAC address of forwarder 2. When I am saying forwarder 2, it means I am saying active router for forwarder 2. Right? like it is like this: AVG, AVG. For AVG, R1 is my active router, R2 is maybe a standby, and R3 is in listen. This is the case for AVF1, or in AVF1, R1 is the active, R2 and R3 both are in listen state. AVF2, router 1 is in listen state, router 2 is the active router, and router 3 is in listen state. And AVF3, why I have 3 AVF? Because I have 3 routers in the group. Router 1 is in listen state, router 2 is also only listening, and router 3 is forwarding traffic. So this is active, right? So sometime in short I can say router 1, R1 is forwarder 1, router 2 is forwarder 2, router 3 is forwarder 3. It means active router for AVG, right? And if you will create 2 group, 2 GLBP group, GLBP 10 and 20, then 2 AVG will be there. And how many AVF will be there? 6 AVF will be there. Right? Those are advanced concepts. No need to learn that now. Just practice these basic things of these all protocols. That is more than sufficient for you now. Okay, that's all for today from my side.
Yes.
Now we'll proceed from here tomorrow.
So what's the topic?
Thank you. Good night.